Good morning. We are on lesson 4.4. It's called Proving Triangles Are Congruent, and you see these acronyms, SSS and SAS. These are just abbreviations for the side-side-side postulate and the side-angle-side postulate. The great thing about these two is like if you remember in the last lesson, when we were trying to prove two triangles were congruent, we had to prove that there were three congruent angles and there were three congruent sides between the two triangles that were congruent to each other. So that was like a total of 6 things that we had to verify that there was congruency. So the thing that's really nice about these postulates we're about to learn is that you don't have to have all that. If you have 2 triangles and just the 3 sides are congruent to each other and you don't know anything about the angles, you don't need to. You already know by this postulate that they are going to be congruent to each other. So think of these as shortcuts. And so the first one we're going to look at specifically is the side-side-side postulate. And so if you read the top here, just like I said, in 4.3 we proved that 2 triangles were congruent by showing that all 6 pairs of corresponding parts were congruent. And again, that means your sides and angles, because that's what makes up a triangle, is the parts are the sides and the angles. And so now we're going to prove 2 triangles are congruent using fewer pairs of things, which is nice. So the first postulate is if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. And you can see that by the picture here. And in this section right here that I'm circling, that just shows you specifically which sides are congruent to each other. And you can also tell by the picture and the congruency marks they make, you can see it visually. So therefore, if we can prove these 3 pairs of sides are congruent to each other, then we can say this right here, which I'm going to underline in red. Then simply by knowing those sides are congruent to each other, we can say the triangle ABC is congruent to triangle DEF. And don't forget, order matters. We cannot say triangle ABC is congruent to EFD. We have to make sure we line up the sides. And if you're confused about that, just look real quickly with me. Just as an example, it's kind of a nice review of the last lesson. See here where AB is congruent to DE. And remember I said you can correlate by the order of the congruency statement, like which segments are congruent to each other. So if you'll notice on the triangle congruency statement down here that AB is listed first and so is DE in that order. So that's why you can say AB is congruent to DE from that statement. And so that's also how you know to write the congruency statement. You have to make sure that if you're mentioning AB in your congruency statement on this first triangle is AB first, then you know you got to list DE first on your second triangle when you're naming it. So, and then likewise, BC is congruent to EF, and you'll notice that BC on this triangle, the list that the way they list the letters on the triangle, BC and EF are both in the same positions. And finally, I'm going to erase this stuff because it's getting really, really hard to see. And then finally, because AC is congruent to DF, you will notice AC is written first and third, and DF is written first and third. So that's how you know what order to write your congruency statement. You just look at your list of congruent segments and go from there. And the first triangle, the order does not really matter. It just means that that's going to dictate how you need to write the order of the letters in the second triangle in your congruency statement. Okay, just keep that in mind because that's something we pointed out in the last lesson. Okay, the second one I mentioned was side-angle-side congruence. So basically it says, any two triangles formed using the same side lengths and an included angle. That is really important, okay? Included angle. I'll mention what that means in a minute. So if you have two sides and an included angle, then you can use this postulate. What the included angle means is that it is the angle between the two sides that you know have a congruent partner with the other triangle. So they word it really well, I feel here. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. And you'll notice in both these triangles over here, the angle between the two sides here is in between. So kind of think of the included angle as the angle that is formed by the two rays that make the sides of that angle. And so it has to be included. So I'm going to erase this here. So you cannot do, there's no such thing as an SSA postulate. Like, I could not do this. This would not prove, this would not be using SAS properly if I did something like this. Okay? That angle in these red triangles I just drew is not between the two sides. Okay? In order for this to work, I would need the angle to be this one here. Okay? That would work. And if I knew these others were, congruent, so be it. But that's where it's got to be. It's got to be between the two sides that you know are congruent with another triangle, okay? And so, again, I won't go over it in detail. When you list your congruency statement based on these, you have to make sure the segments or the angles that are congruent line up, okay? All right, next. We have talked about paragraph proofs. We've talked about two-column proofs mostly. Just in case you've forgotten, or maybe I haven't mentioned it much yet, about flow proofs. Basically, flow proofs are very similar to two-column proofs, just like paragraph proofs are similar to two-column proofs. They just look different. Flow proofs are using basically a flow chart, and basically the box, inside the box contains your statement. The wording below the statement is your reason, okay? And then you just follow the arrows, and the arrows can be going every which way. You just follow the arrows. And so, and two, you can have where it's a nice flow like this, where you have, one going there and then down there. And sometimes you might have more than one chart item point to more than one box. It just depends on what's in the box before it, if it applies or not. So just keep that in mind. If I ask you to write something in a two-column proof, but the answer key in the back, they wanted you to do a flow proof, just look for your statements and reasons to line up that way from the flow chart by looking what's in the box is your statements, and then the order is dictated by the arrows. So in the one that I did here, seems like everything's flowing from here, so that's probably going to be the first statement and reason in your proof. And then from there, you might be able to make two conclusions, and so it really doesn't matter if this is your second statement or that's your third, but again, if you're going to use it this way, this would be gone, okay? And so you could list either one of those as two or three, but I would just go in order of appearance as you see it. Usually we work top to bottom, so more than likely your two-column proof would list the first statement reason, and then the second statement reason that's on top, I would list it second, and then list the next one third. So just wanted to point that out there in case I have told you to write it as a two-column proof and the book tells you to write it a flow proof. You can still check the back of the book and see if you have the right statements and reasons, okay? Now, let's move into some problems. we're going to be working on starting on page, the problems start on page 268, but we are jumping to 270 because that's where the first problems I have listed are where they are. So we're going to jump to 16 and 18 because it's not writing a proof, it's just identifying whether or not you can use postulates to prove they're congruent. And I feel like that's where we need to start with that. So we'll do that first, and then, so we're going to do page 270, 16 and 18. Then we're going to go back to number 4 and then go back to 28. So I'm jumping around a little bit. And then the ones I'm going to have you do on your own, they're going to be odd number problems. That way you can check your answers, all right? So let's go ahead and jump on over to number 16. So 16, the directions, as always, we need to read the directions. It says, determine which postulate can be used to prove that the triangles are congruent. And again, in this lesson, we've only learned about side, 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 and side, angle, side. So you got 50-50 chance. But if the picture does not give you enough information to use either one of those, we're going to write not possible. So I'm going to do 16 with you. If you'll notice with me that these two triangles both have congruent side parts, okay? So, for example, this one side is congruent with this side. This side over here is congruent with this side because the congruency marks, the number of them match each other. Okay, so this is a perfect example of the side-side-side postulate. So we're just going to write SSS. All right, follows it perfectly. Let's jump to 18. Okay, so 18 has a side and a side that are congruent, another side and a side that's congruent, and an angle and an angle. So at first glance you might think, oh, two sides and an angle, that's got to be SAS. But remember, SAS is very prescriptive. It has to be the two sides, but with the angle in between the two sides that's congruent. And I'm going to erase what I circled here, and you'll notice that this angle is not between the two sides. This is how it should have been. If we were going to use SAS, we would need to know that these two angles are congruent. Let me make that a little neater. Yes, we would need to know that this angle and this angle are congruent. Then I would have had side, angle, side. So I kind of think of it as an angle sandwich between the two sides, or between the two sides. And so because of this, this isn't going to work. And the reason for this, why it doesn't work, is if you tried to draw these two triangles, you would find that you could, just by knowing or having these be congruent to each other, you could actually create triangles that are not congruent, even with those being true. And so that's why it does not work. If you want to try that out and have, two sides are congruent and then that particular angle being congruent, you can see that you can still maybe make, let me erase all this, you can still make maybe these angles right here be different than each other, okay? And if you play around with it, and you'll see that it in order for them to create two congruent triangles, that angle between them has to be congruent. And so if you don't do that, then you can alter the triangle and still have the two congruent sides that they say and the two angles they say congruent, but you can still make them be different and not congruent. So that is the reasoning why is this. So our answer for this is going to be just not possible with this information, okay? We would need to know more information before we could say that these are congruent to each other, okay? We would need to know more things are congruent on it to verify. I mean, they could be, but it's not possible to tell right now. Okay, we're going to move on to number 4. All right, so let's go back a little bit. Oh, maybe I need to go forward. Let's see. Let me find number 4. Oh, I put it in the order that we need. Okay, so this one's to write a 2-column proof. And so we're going to get some practice with that. So when we're writing a 2-column proof, I'm going to be going to a blank sheet of paper, or I'm going to try and squeeze this in down here where I can. I might write it up here at the top, the proof. And it'll be going kind of sideways just because I'm running out of room. But I want the picture here available to us at the same time, so bear with me. All right, here's what they give us. They tell us that BA is congruent to DC, and if you look at your picture over here, they marked that congruent already for us. They also marked congruent that BAC is congruent to DCA for us. Okay, so now they want us to prove that BC is congruent to DA. So, right now we have a congruent side on each triangle, and we have a congruent angle. Right now, at first glance, it looks like we don't even have enough information, but actually we do, because we know that both of these triangles share this common side right here. And so actually I can mark this congruent, and because they both share triangle ABC here shares the same side AC with the other triangle ADC. And so basically now we've got a perfect example of side, angle, side on this triangle being congruent, and I'll do a different color so we can kind of see the difference. We have those side, angle, side congruent with another triangle who also has a side, angle, and side, okay? And so we do have enough information. We can actually prove that BC is congruent to DA. Now you might be thinking, wait a minute. The postulate says you can prove the 2 triangles are congruent, right? That's what the postulate does. But there's this other acronym I have not mentioned yet today, and it's called CPCTC. And what it says is congruent parts of congruent triangles are congruent. And so that just simply means if you prove 2 triangles are congruent, like by SAS, which we're about to do, then we can pick out the congruent parts and finalize our proof. Because we know that if we've proven 2 congruent triangles, or 2 triangles are congruent, then their corresponding parts are going to be congruent, right? So that's just, so what we need to do first is prove the 2 triangles are congruent and then go from there. So let's start this. So I'm going to begin my proof up here, all right? And as you know, we always begin by labeling our 2 columns, statement and reason, and we always put our given first, and that's always our reason, okay? And our given is BA is congruent to DC, angle BAC is congruent to angle DCA. And I'm going to clean up that one angle I made. So that's just the given. So we're going to get started. Now, also, as we pointed out and like I've always stressed, you want to look at the picture and see what else you can conclude from the given. And one of the things we realized from the picture is that AC, that segment AC side, is shared by both triangles. So we want to mention that. So we're going to say that AC of one triangle, segment AC of one triangle, is congruent to CA of the other triangle, okay? And the reason we reverse the order, we don't just say AC is congruent to CA, we reverse it because if you were naming these 2 triangles, they would be in reverse order because angle A and angle C are the corresponding angles, okay, that equal each other. So just keep that in mind. So our reasoning is going to be the reflexive property of congruence. Okay. So now we basically have everything taken care of. We've got two sides with an included angle between them proven to be congruent. So now we can conclude, so I'm going to put number 3 over here. And we're going to be able to say, hey, triangle BCA, and you could call it triangle ABC, okay? It really, the first triangle you mentioned, you pick the order, but I just picked BCA. I picked B and then went around clockwise, okay? But because I picked that order, that's going to dictate my order of the second triangle, okay? So if you look, angle B and angle D are congruent angles, right? So since I listed B first on the first triangle, I'm going to list D first on the second triangle. And then if you look at the next letters that need to happen, it's going to be C is congruent to A on the other triangle, right? If you look at the figure, you'll see that. Angle C and angle A on the two different triangles have the same congruency mark, okay? And then the last letter, just by default, you don't even have to think about it, is going to be C, okay? Because that's the only letter we haven't used yet. And so our reasoning for this is going to be SAS. So I'm going to write that over here. And that's all I got to write. We've proven those two triangles are congruent. And now that we've proven those two triangles are congruent, we can prove now any sides, any angles are now, we can pick and choose what we need. And what we need is we need to prove that BC, side BC, is congruent to side DA of the other triangle. And we don't have to write out the full words like corresponding parts of congruent triangles are congruent. We can just simply write CPC TC. Very thankful for abbreviations like that. So that means corresponding parts of congruent triangles are congruent. So we can pick any corresponding parts we need. If they wanted us to prove that angle D is equal to angle B, I mean, we could do that now. We could just, and our reasoning would be CPCTC, okay? We could pick all sorts of things now out of these these two congruent triangles and prove congruency between the parts. But you always got to prove the triangles are congruent first before you can start picking and choosing what you want to prove is congruent on the parts, okay? All right, so that concludes our proof for number 4. All right, the last one we're going to do is number 28. So let's see which way I need to go. Where's my 28? Okay, it's this way. All right, so 28 is our next option or next problem. And they tell us right away in the directions, find the value of the variable that yields congruent triangles. Okay, so basically they're saying solve so that these triangles are congruent. And they already tell us they are, so it's not like you're making something up. They're saying triangle ABC is congruent to triangle FGH. All right, so that's where we're going to get started with. So what I can do now, because I have that congruency statement, I am able to show or figure out which sides are congruent to each other and which angles are congruent to each other. So from this congruency statement, I know AB is congruent to FG because they're both listed first, and they're the first and second letter listed in my congruency statement up here. And what I mean by up here is this right here, AB, FG, okay? So I know those are congruent. Also, I know from this congruency statement, I'll do a different color, I know BC is congruent to GH. So I could actually mark those two now congruent if I need to, okay? So I'm going to put BC is congruent to GH. Next, I also know, and I'll do a different color, that AC is congruent to FH, right? So I can mark those. AC is congruent to FH. So there's actually a lot of options on what I can do to solve for x, right? So it really doesn't matter. I could set up really 3 different equations to find x. I could set 2x plus 5 equal to 11 because they're congruent. I could set 7 equal to 3x minus 2 and solve for x because they're congruent. And then also I could set 4x plus 1 equal to 13 because they're congruent. So just pick whatever you think the math would be easier, okay? I'm just going to pick the last one because I'm already in blue. Why not? So I'm going to set 4x plus 1 equal to 13. Why? Because I know FG is congruent to AB. And therefore, the measures are equal to each other, okay? And I don't know the measure of FG because I don't know what x is, but I'm going to do that now. So I'm going to subtract 1. I get 4x equals 12. And after we divide both sides by 4, we know that x is 3. So we've found the value of the variable, okay? And so then they want us to explain on how that yields congruent triangles. Well, we know they're congruent because of the congruency statement, okay? So we know that's going to work. So therefore, like I already said, basically in my diagram, that AC is congruent to FH. Now, if you don't want to draw the diagrams and show the congruency, you can write these explanations out like they want us to. They want us to write out AC is congruent to FH, okay? They want us to write out that basically everything I said. BC is congruent to GH. And then they also want us to write out, let's see, what have I left out? BC I did, okay, so AB I think I left out. AB is congruent to FG. Now why is that? If you remember at the very beginning, I was saying all this because of CPCTC. So we're saying all three of these are congruent because this is our reasoning. That's our explanation because of CPCTC. So again, I'm game if you want to copy these down and show it this way by doing the congruency marks and then saying CPCTC, or you could just list out, you know, what I just did right here. Or draw the diagram showing the congruency, but either way you still need to end with CPCTC is how we figured out the value of the variable. Okay. All right. That's it for today. Be working on your problems on your own, and please refer to this video for any review that you need. Bye now.